right, class.
Yes.
So, we're going to go through and actually do these problems because, you know what, you guys are here to learn and I'm here to teach. So, going over this. So, if you started this first problem right here, what am I going to do with that x value? Not factor, not turn to 0. It says right here, x is 2. What am I going to do with that? Let's plug in. Go ahead, let's plug in. So if I plug it in, it's going to be 2 times 2, 4 plus 5, 9 over 2 equals 7 times 2, 14 minus 5, 9 over 2. Okay, so now let's try it on this side. So for B, it's going to be 2 times 2 is 4, plus 5, 9 equals, we're doing B, it's not an over. So again, 7 times 2 is 14, minus 5.
9.
There we go, so 9 equals 9. So if you notice these equations, they're all going to be equal, aren't they?
Yeah.
Okay, so let's see if we get one that's not. For 1, x equals 1. So 2 times 1 is 2, plus 3 is 5 over 1 plus 2? 3. Equals 4 times 1 is 4, plus 1? 5 over
3.
5 over 3. They're equal again. Next one. It's going to be again 2 times 1 is 2 plus 3. 5 equals 5. So right here, by plugging this in and seeing, it's all going to be the same thing because they're common denominators, right? The denominators are the same, so it doesn't matter if I'm including the denominators or not. I'm going to get the same answer on top, right? So, let's take a look at this next one. There. Okay, so my problem says the school art club at a large high school is in charge of designing school t-shirts, getting them printed this year. A local business charges $35 to set up their t-shirt printing machine with the design and $4.25 in materials per t-shirt to print. Create an equation to represent the average cost, C, in dollars per t-shirt, X. T-shirts are printed by this business. So now we're going to do an average cost. So the average per t-shirt. So first let's figure out the cost. How much do I have to pay no matter what? 35, right? That's a setup. So no matter, so if I order 0 shirts, I'm still going to have to pay $35, right? Because that's going to be my setup. $35 to set up. So it's going to be C of X, 35. Now I'm adding. So now, yes, go. I'm going to have a rate. So how much is it per shirt? $4.25. And now I'm going to have multiple shirts, right? So it's going to tell me how many shirts. So it's going to be an X, right? Plus 4.25x. But now I want the average cost. The average cost. So the average cost of this, so this is just going to be the cost of the shirts, right? So that's the cost of the shirts. Now, and it depends on how many I order. So what would I put this over? X. Because I'm going to divide that by how many shirts I order. So it's the cost divided by how many I'm getting. So now that I have that, so what is the average cost per shirt to print 25 shirts? So what I'm going to do with that 25? Plug it in. Y'all got this thing on your calculator? It's called a calculator. So everyone should be calculating with their calculator that I know that they have. What you need?
I can talk to
The dean?
No.
Are you in trouble?
No, I just need to get my ID back.
Oh, okay. Can it wait till I'm done? Yeah. So what are we going to get? Divided by this.
Do you plug 25 into the top x and bottom x?
Yes, both x's. So it's going to be c of 25 is equal to 35 plus 4.25. So it should look like this. Okay, so what are we going to come up with here? 116? I need the whole thing. Give me total value.
5.65.
What?
5.65.
5.65. That's better. So what does that mean? Each shirt is going to cost me $5 of 65 cents, right? So what if I bought 0 shirts? It would be basically 35, right? But I can't really divide by 0, so that doesn't work. So I have to at least buy 1. But it comes out to be almost $35. So it's no fun. No fun. No fun. All right, so now let's do it again for 100 shirts. So you're doing this for 100 shirts. For 100 shirts, like the calculator which I asked you to have, which you should be calculating. Where is your calculator? And I was trying to give you a hint. You made eye contact when I was staring at you right there, and you're like, no, go get the calculator.
4.6.
So for 100 shirts, if I do this function again, this is going to give me $4.60. There we go. So doing the same thing, just replacing my x value with 100 this time. So what does that tell me? What does that tell me from here to here? Very good. The more you buy, the cheaper it's going to get. So the more you buy, the cheaper it's going to get. Now, what is the cheapest average cost t-shirt we'll get? Explain to show your reasoning. So we're going to explain our reasoning on this. So I have my function, which is the cost of x. 35 plus 4.25x over x. Now, I want to now talk about end behavior. End behavior would be the cheapest it's ever going to get. We have to think about what we did last week on this. We were talking about end behavior last week. How would I do an end behavior last week? I'm gonna get that. I'm gonna get that, but not yet. So from last week, I had a problem like this. Do you guys remember we're talking about a limit going to infinity? So we want to try and take this to infinity to see what I get. Before I do that, what did I have to do? Yes, I'm looking for a horizontal asymptote. I'm looking for a horizontal asymptote. So what would I do to try and do that? Not graph. The graph is not going to help me on this one. Okay, but starting with this right here. Starting with this, what is this going to do? You know you guys got the notebook. You can flip back a couple pages. Go down? Flip back a couple pages. Everyone should have your notebook in front of you. Everyone should, come on, I'm trying to help you. Your notebook, huh? 57, it could be 57, it could be 55. Everyone's notebook should be in front of you right now.
But I didn't.
Then get it out. So, in that notebook, that's the reason why I keep preaching the same thing.
It's 59.
59 is today's. So it's got to be 57 or 55, maybe even 53. What's the end behavior going to look like? Zero, no. Not multiply times x. I'm trying to figure out the end behavior. What is this going to end up at? What can I do with this fraction right here? I'm trying to give you a hint. What do we do with this fraction right here? We did it a whole bunch of times. Separate it. Thank you. Separate my fraction. Separate my fraction. 35 over x plus 425x over x. Do you remember this now?
Wait, wait. Right here. Oh, okay.
So now, if I take this to infinity, I want to know what the end behavior is. If I take this to infinity, what is 35 over infinity? That goes to 0. Because if I'm dividing by infinity, it's a big number. So this ends up just going away. So the bottom number is huge. So this goes to 0. What about x over x? Those cancel. So I'm going to be left with what? So the end behavior. So the cheapest this is ever going to get is $4.25. How many shirts should be printed to have an average cost of $5 or less per shirt? All right. So I want my cost to be $5 or less. So the C of x cost is going to be 5. But I want it to be that or less. So alligator eats the bigger number. So 5 is going to be bigger than whatever my function is. Now my function, I just bring this down. 35 plus 4.25x over x. Now, I'm going to try and solve for x here. I'm going to try and solve for x. Now, I have a fraction here. I want to get rid of my fraction. How am I going to do that? How am I going to get rid of my fraction? Multiply both sides by x, which is my common denominator. I only have one denominator here. So I'm going to multiply both sides of this by x. Five x, 35 plus 4.25x. just like I said last week, what do I do next? My x's get left. What am I going to do to my x's? Add? Subtract. I want my x's on the left over here, don't I? So, yes, I'm going to subtract. I'm going to subtract 4.25x. So it's going to be 0.75 is equal to 35. 0.75x, sorry. Now, is x by itself?
No.
What you going to do now that trying to get x? Divide both sides by 0.75. So everyone in your calculator is going to do this for me. Now, speaking about the calculator thing, I keep emphasizing the calculator thing. How many people realize you could do almost the entire test in the calculator last week? One person. I keep having you guys use these calculators for a reason. I keep trying to show you guys how to use these calculators. And I can't get some people to even go get the calculator. So right here, x is going to be how many? Huh? Okay, there we go. Now, let's go back to the information. X represents what? Number of shirts.
What's your calculator?
Where? So, okay. We're talking about number of shirts, right? We're talking about number of shirts. What is that going to give me? Let's talk about people on a plane then. How many people can we have on a plane? No negative and? No half people. No fractions, right? We're talking about t-shirts. The only fractional t-shirt we're talking about here would be that one right there. But we need to make sure that they're whole shirts. Just because you buy it on sale, it doesn't mean it's half off. Okay? So, how many shirts do I have to have here to actually get this? Nope. 47. You have to go up. You have to go up because it's got to be a whole shirt.
Oh yeah, you're right.
It's got to be, remember, alligators got to eat this or more. Yes?
Yeah.
So it's going to be 47 shirts. There you go. 47 shirts. Now, this next one. Tyler's on the school baseball team and he has 24 base hits out of 100 bats this year. What is the current batting average? How do I figure out that batting average? Divide? Yeah. So it would be give me a decimal. It's got to be decimals. So it's going to be 0.0 Okay, so that is a batting average. It's always in decimals, and it usually uses 3 decimal points. He wants to raise his batting average to 300. How many of his next consecutive at-bats needs to base hits, raise his batting average to 300? Write an equation, write and solve an equation to describe the situation using X number of consecutive base hits So let's take a look. My batting average, I want it to be 300. How many at-bats did he have? There's 110, right? Okay, how many hits does he already have? But he's going to get a hit on his next at-bat. So what's that going to change? It'd be 25, but we don't know how many hits he's going to get, though, right? We just know that he's going to get a bunch more hits. What am I going to do? What did you do right there to get 25? You added, right? So we're adding so many, aren't we?
Yeah, we're adding X.
We're adding X. But if he gets that many more hits, doesn't he have to get that many or more at-bats?
Yeah.
So I also have to have right there. So that means that it's going to add the same amount of hits, right? So adding those and then adding those. Now we're going to go through and try and solve for this. Now to solve for this, I need to multiply by the common denominator. My common denominator in this case is what?
X.
No, it's not X. It's got to be the whole thing. 110 plus X. It's the whole denominator, right? So I'm going to multiply by and I got to do it to both sides. Someone else is gone. Angel's gone. All right. These going to cancel on this side. Now over here, I have to distribute. So that's going to be 0.33
Yep.
plus 0.3x equals 24 plus x. Now I'm trying to solve for x. So it's the easiest thing is going to get my x's all to the right because this one's smaller than that one. I'm going to subtract 0.3x from both sides. So, and I'm also going to subtract 24 from this side. That should be 33, not 0.33, right? Thank you, thank you. There you go. Okay, so minus 24. So on this side, on the right-hand side, I should have 9 equals 0.7x. Now what? Divide both sides by? So how many hits? 12 point what? So x has got to be but x represents the number of hits, right? Number of hits. We can't have 0.85 of a hit. So it's going to be next 13 13 at-bats. So right here, so it's going to be number of consecutive hits, so that's going to be 13 consecutive hits. Unfortunately, Tyler gets no base hit in his next 3 at-bats. He gets no base hits at his next 3 at-bats. But he still wants to get a batting average of 300. Now we're going to revise this. So you, the student, are going to set this one up. You're going to set this one up right now and solve it. I'm going to give you a couple moments. I want you to set it up and start it. I want you to set it up and start this one.
Can I get my pass now?
I'm still not done.
Or
Okay.
is it not done?
Oh, I know. If you're just sitting there, watching Netflix or whatever, then, probably you don't need any help, do you? No. Are you Netflixing over here? Is that what it is? Am I interrupting?
No, it's just
No,
chilling
it's-
there. Do my work.
So you say.
Well, by the time you do it, that was when you done the work. Get your hands up, Tyler.
Yeah, it's right there somewhere. You can at least write down what I'm writing. Come on. Don't worry about this.
So this is the work.
Oh, you're writing it for both? She's got something else to do.
I was expecting you guys to say like now.
This part right here, this is what I'm at. This part.
Isn't that what she said to me? She said like that artist or no? That one she draws like
All right, let's see. Okay, Jonathan, pay attention, please. Okay, I asked you guys to set up this problem. I asked you to start doing something on this. So, how many at-bats do we have now? How much? Wait, no. Okay, I'm setting up the problem first. Let's set up the problem. How many at-bats do we have now? So, he struck out 3 times in a row, right? So how many at-bats does he have now? 1 what? 113. How many hits does he have?
3.
Did he get 3 hits?
No.
He struck out 3 times. How many hits does he have?
X.
He still has 24 hits, doesn't he? So that's not changing. We still have 24 hits. Still have 24 hits. Does he still want the 300 batting average? Now we're going to ask how many more consecutive hits is he going to need? Plus X and plus X. All right, so now I've set this up for you. Now I want you to finish this then. someone else restroom. Who has restroom? She has restroom.
I asked.
I got it up there.
I know, but where?
Is that accurate?
Hmm? No. It's the same. We gotta do the same step though. Gotta do the same steps. So, like I said, same steps. What am I gonna multiply both sides by? There you go. Same thing to both sides. You're not putting it in yet. You have to do the algebra first. Distribute, same way we just did it a little while ago. No, this is still 0.3x. 113 times 0.3. 33.9 equals 24 plus x. You don't do anything. What's hard? You sit there and just play on your phone the whole time. You don't do anything. Look, it's blank still. Yep. Subtract 0.3 x and the 24. So I should get 9.9 is equal to 0.7 x. 0.7, right? So x.
What do we have to get, like 15 hits?
15 hits, because it's got to be that or more, right? So if I only get 14 hits, I'm going to be less than. And at-bats and hits is like, you can't have a fractional at-bat. So in this case right here, it's going to be 15. So I'm going to end up with 15 consecutive hits here. Yeah, that was the third one. Huh? Oh, no. Okay, so I'm going to actually leave off on that one. There's an extra one here. So this, huh? This? Yeah. Okay. All right. So now I want you guys, please, okay, your practice problems. Okay, these are going to be due in 2 days.